Welcome everyone to this FT Live event on lower carbon transport. Today we're focusing on the role of renewable gasoline, and I'm joined by two experts to my left. First is Dr. Gil Pratt, who is the Chief Scientist at Toyota Motor Corporation and the CEO of the Toyota Research Institute. And to my immediate left is Andy Waltz, who's President of Americas Products for Chevron. Thank you, gents, for joining me. Thank you, audience, for being here. Let me start with a very, very basic question for you both, and that is, what is renewable gasoline? What are we talking about? It feels somewhat new. We know about ethanol, I think. We know about biodiesel and those kind of things. What is renewable gasoline? Let's start with you, Andy.
Okay, well, good question. You mentioned biodiesel, renewable diesel. We've been making those products for a long time. Those are drop-in fuels that go into vehicles today. They reduce the carbon intensity of that transportation sector. And for a while now, we've been working with Toyota on renewable gasoline. We believe we should find a way to decarbonize the light-duty vehicle segment of transportation. It's the vast majority of vehicles out there today. In fact, in the US, it's like 265 million vehicles today. And we've got to find a way to do it. So renewable gasoline is a way to decarbonize the existing fleet in the United States and elsewhere in the world without having to replace equipment, buy a new vehicle. So that's what we're here talking about.
And just walk me through how you actually do it. What is it? What's it made of? What is the renewable part?
Yeah, really good question. So we have a bunch of different formulations that we've come up with while we're researching this, but essentially we're taking some fossil gasoline or fossil fuels, we're combining that with additional ethanol, hopefully low carbon ethanol. We're combining it with bio feedstocks, sometimes soy, other feedstocks. We're sometimes including renewable naphtha, which is a byproduct for producing renewable diesel. You put all that together, and we think we can reduce the carbon intensity of that gallon of gasoline by about 40 or 50%.
And that includes the whole supply chain to make these vehicles or to make the fuels? How do you calculate that?
Yeah, so the product is about 50% lower CI. If you look at the carbon intensity of the entire value chain, including the manufacturing of the vehicle, it's about a 40% reduction, which is a material reduction for a fleet that's on the road today, and we'll be on the road for a long, long time.
Okay, and Gil, how do you see this working in a Toyota vehicle or any vehicle?
Well, one of the most important things to do is to understand that if we want to reduce carbon as much as possible, as soon as possible, that we have to take a multi-pathway approach. And so we see this as one of the pathways. As Andy said, it's incredibly important for what we call units in operation. These are vehicles that are already on the road, that will be on the road for perhaps 20 years to come. What else are we going to do? We can't change those vehicles. Let's find a way to fuel them with lower carbon fuel. We also think it has a role in some newer vehicles as well for parts of the market where battery electric vehicles don't make as much sense. Now, we're going to be making a lot of battery electric vehicles. We've publicly stated that the target for 2030, only 7 years from now, is 3.5 million vehicles per year. And most recently, actually last week, we gave an update on our near-term goal. Only 3 years from now, it's 1.5 million vehicles per year for new vehicles. But it's not all vehicles, because some people in some parts of the world will live in areas without renewable electricity for recharging them. And some people will have lifestyles or little access to renewable power charging that will allow them to take advantage of battery electric vehicles. And for those folks where some gasoline is still going to be used, we think it's incredibly important to lower the amount of CO2 that comes out. So it's not an either-or choice. It's a yes-and choice to try to lower the net carbon emissions as much as possible.
Okay, so we'll come to the kind of EV argument and the decarbonization stuff in a minute. Mm-hmm. But just so I really understand and the audience understands how this will work, when I drive up to a filling station somewhere in Chevron station in my Toyota,
yes.
If only, then I go to the pump.
Yes.
There's a separate pump, or there's the same pump, or how is it going to work?
Andy?
Yeah, that's probably directed toward me. If you pull up to your Chevron station, it'll be a separate product on the Bowser, on the pump, mm-hmm. and they'll just select that button. They'll put the same nozzle into their car. They can put it in any car they're driving today, and they'll drive off just like they did, and they'll have a lower carbon intensity gasoline in their vehicle.
And it carries the same
Efficiency,
punch?
same properties, does no damage to the vehicle. We've done a demonstration for the last few days where we've had it in new vehicles, in old vehicles, and it works really well. We've done a lot of testing with Toyota, and this is a really good product.
And how much will it cost?
Yeah, so cost is going to be an interesting conversation. Lower carbon products are more expensive. We don't know what it's going to cost today. We're in the formulation stages. It probably is going to cost more for the consumer. I don't think it's going to be a lot. As we get scale, we think that cost comes down. It becomes much more competitive, and we're kind of at the starting gates here, and that's what we're thinking about.
And again, I think the important thing is to consider what are the alternatives. So, there is a value to reducing CO2 emissions that comes out of cars, especially out of older cars. Globally, it's 1.3 billion vehicles in the world that are using gasoline today. And the thing to really understand, and what I think about as a scientist, is that CO2 that we're emitting today is going to be around for hundreds, if not thousands of years. And so every little bit of CO2 is something that we need to reduce now as much as possible and as soon as possible. And the only way that we know to do that for existing vehicles is actually low carbon liquid fuels.
And if you, a little bit more on the cost, if you think about the cost of, there's no additional infrastructure that's required. We don't have to build a different service station. You don't have to buy a new car. So there's some costs that don't have to be borne by the consumer. We don't have to have new power generation. So we think it's a really good solution. We actually think it might be cheaper in the long run if you look at the entire value chains for the opportunities.
Do you need to build a new refinery?
No, we're modifying our existing refinery. We're putting different products into that refinery. We're starting to learn. Do we need some different metallurgy? We don't know all that yet, but we're making it at our El Segundo refinery. That's where we intend to make it today.
And just ballpark, what are you looking at in terms of the size of this market, in terms of, I don't know, market share of fuel demand at the moment, or how many barrels per day, or whatever terms you have?
Yeah, I'm really not very good at predicting the future, but I will say that I think this is going to be needed. It's necessary that we get after taking CO2 out of the transportation sector. It is very small today, it's nascent today, but we're only kicking this off. We started talking about this on Monday. We're excited. We do need this to be an industry approach. We need other refiners that we compete with to be thinking the same way. I think you've seen that Exxon's kind of got the same mentality. So we think it's early, but there is a big market there. We think it's important, and it's hard to predict where it's going to go.
Okay, and Gil, why not just spend this money? I don't know quite how much money you're spending on this, but why not spend this money on EVs or reinforcing the EV charging network, or other decarbonization efforts?
The reason not to put all our eggs in one basket is that we actually don't get the optimal result when we do it, and it's much higher risk when we do it. We know that this transition is going to take time, particularly in parts of the world that are less developed than where we're sitting right now. And so there's also customers for whom the EV, or BEV as we call it, solution is actually not the optimal one. And we can't force customers to choose a particular type of car. We can incentivize them to do it, but ultimately they actually make the decision. And right now, during this transition, we think that it's important to provide those alternatives in a way that we can get to our carbon neutrality goals, regardless of what that path happens to be.
Maybe just to build, we're working with Toyota on hydrogen. That is a light-duty vehicle that's got a future. We're spending time with them in California working on that. And I also think as you start to scale up that platform or that value chain, the electric value chain, there are going to be bumpy roads. There are going to be challenges with that. There are going to be unforeseen challenges that don't work, and so we need all options. This is an additional option. It's not an alternative. It's just another option, another way to get to the same outcome.
And it will be potentially more expensive for the consumer. For Chevron, do you have to commit, do you have to go to Mike Wirth and ask for more in the budget to build more capacity?
Yeah, well, this is an investment in the future of future fuels. It's I think what the consumer wants. They would like to be able to buy a product that is lower carbon. We are on the cutting edge of this. We've got it in our budget. We are spending this money. I don't think I have to go to Mike, but Mike is clearly aware of what we're doing, and he's supportive of really pushing this opportunity and creating the option for customers to decarbonize transportation.
And how much is that over what period of time at the moment?
Well, I'm not sure what your investment is in that, but what I would wanted to add is that in terms of limited resources, it's very easy to focus on money as being some sort of fixed pool, and well, wouldn't you rather spend the money on A versus B? But there are other resources that are quite limited that are much more of a bottleneck than finances are. And right now we have a limitation in battery materials. So lithium is one of them. The price is fluctuating all over the place. But if you look at the supply and demand curves, every organization that we know of that tracks that is predicting a tremendous shortage that's going to happen over the next 10 to 20 years. And so we know that the supply of battery materials for making batteries will not be sufficient for a faster transition to battery electric vehicles. That's okay, but we need to figure out how to solve climate change despite that limitation. The other limitation is the rollout of renewable charging. Again, it can be done, but it's going to take time because that process itself takes time. And it takes time, for instance, to enhance the electrical grid, to get the permitting for the amount of transmission, to get renewable power from where it's generated, where the sun shines, where the wind blows, to where people live, which tends to be in other places. Again, that's going to take time, so it's a very severe bottleneck on the adoption of battery electric vehicles. So the big question is, since we know CO2 accumulates so much over time, how can we still achieve these carbon goals with other pathways that will also get us there?
Again, and it's a drop-in fuel. So we're making it at our refinery. We're taking it through our pipelines to our terminals. We're putting it into the service station that's currently exists today. So I really don't think the cost for this incremental product is all that much because it's using the existing infrastructure.
Okay, and Gil, you talked about the lack of availability, I guess, of critical minerals.
Yes.
I think you were referring to. What about the availability of the feedstock for this stuff?
Yeah.
Because there are a lot of people who would say, for starters, some of that is food,
Yes.
Whether for animals or humans.
Yes.
And there are finite amounts of this stuff that can be turned into renewable gasoline. How do you deal
Yes.
with that conundrum?
So I'm not an expert on it. Actually, I think Andy knows more, but what I can say to kind of start the conversation on that is, of course, that's not infinite either. And so what we have is a number of resources, each of which is a bottleneck, and they are finite. But does that mean that we should only choose one? And so the same argument to say it's not all BEVs, we shouldn't have a single put all your eggs in one basket solution, also says it shouldn't be also only liquid fuels, only low carbon liquid fuels. That's not what we're saying. We're saying that if we have multiple solutions, they're additive. They aggregate with each other, which I think is something that we must do if we want to minimize the amount of carbon that is put out. But as to the specifics, Andy?
Yeah, it's a really good question. Is there enough feedstocks today? No, but as you create demand, as you create opportunities, the American farmer is a pretty resourceful business person, and not all feedstocks are the same. You're talking about soy. Soy is an interesting feedstock. That's one we use. We also use a lot of waste products, which are throwaway products. So if you can aggregate those into your feedstocks, like use cooking oil, animal fat, greases, those are also part of the feedstock. Those are the feedstocks we buy today to put into renewable diesel, biodiesel, and those are growing as well. And our view is that as these supply chains develop, a lot like ethanol did many years ago, ethanol started slow, and the American farmer figured it out, the ethanol producers figured it out, and we got to a point where it's reliable and it's dependable and it's cost effective.
And why is it happening now? Because this problem, the problem of emissions through the tailpipe and emissions in general has been around for a long time, as you know. What has changed to make this a viable thing now?
So I think that there's more critical awareness right now of the seriousness of climate change. I think the fact that there have been rather severe weather events that have happened recently, even though not all of them are directly related to climate change, has kind of brought it to the front of mind as, wow, this is really going to get worse unless we do something. And so I think that's the reason for the timing of this. But there's also, I think, a growing realization that it's not a silver bullet answer that's going to solve all of this, that we have to take a multi-pathway approach because each one of them adds additional carbon savings to the answer.
For Chevron, we've been largely focused and talking a lot about hard to abate sectors. And what I mean by that is heavy duty transportation, rail, airlines, heavy duty mining equipment. We've spent a lot of time on that recently. We've been much more public about that because we have those products and we supply those. This product we've been working on with Toyota for quite a while, and we've just decided to unveil it because we're ready, we've got the product, it works, and so that's why you're hearing more about that now. We've been trying to decarbonize all kinds of sectors for a long time, and now we're prepared, now we're ready to talk about renewable gasoline.
Let me raise two, I think, fairly common criticisms, if you like. First one is, you mentioned hard to abate sectors. Some of those, like steel and cement and so on, are going to be very difficult, and they're going to be left for later. At the moment, there is a solution, or there purports to be a solution for transportation, which is the electric battery in cars, maybe fuel cell hydrogen in vehicles, passenger vehicles. Yeah. Why do this now instead of focusing on, say, sustainable aviation fuels, which is another fairly hard to abate sector that can't run on batteries?
So part of the difficulty of that argument is that it's taking a static view of the world. In other words, just an instant in time and not thinking about the dimension of time. If we project, let's say, 100 years from now, it very well may be that battery electric vehicles for light duty vehicles is all that there is. I'm not sure whether that will happen. I don't think anyone can predict it, but that may be the answer. But again, carbon dioxide accumulates in the atmosphere. So all of the CO2 that we're putting in now, between now and whenever that transition is going to occur, is still going to be generated and put out into the atmosphere. And the question is, how can we reduce it during the transition? So again, from a static point of view, it's not a question of which of these is better and then we're done. It's from a dynamic point of view, looking at the progress of time between now and whenever that transition occurs, what should we do? And remembering that we're going to have to pay the cost of all of the CO2 that's emitted during that transition time. And during that time, both because of units in operation, cars that are on the road right now, and also new cars for places, again, where there's not enough battery materials during the transition to go to BEV, or not enough renewable electrical infrastructure to recharge them, all of that accumulated CO2 is something that we want to minimize as much as possible. And that's where low carbon liquid fuels come in.
So the idea is that this is an immediate, almost, solution. It takes some time to get off the ground, I suppose. How long before we will see filling pumps in forecourts across America, or you talked about the developing world. How long until this all starts to actually happen?
Yeah, really good question. We will have pumps in California that are up and running this year. We're going to make some more of the product later in the year, and we're going to have it as an offering. We're going to try it. We're going to figure out how to market it. We have to figure out what the customer wants. We got to figure out how to make it all work, but that'll be happening later this year. We're excited to get it launched and learn and test with the consumer and ask them what they think and get data and figure out how do we take it forward, how do we scale it, how do we accelerate it.
But Gil, predominantly this is for the cars that exist now, right? So this isn't you're not suggesting this is the long-term future for liquid fuels in vehicles, are you?
Well, so I actually want to actually give another vote to what Andy said, which is it's very hard to predict the future. And most technological predictions are wrong. It's something that I learned when I was working for DARPA. And rather than predicting the future—
DARPA being the government—
the Defense Advanced Research Projects Agency for the US. I want to prepare for whatever the future may be and make sure that we have alternate pathways. So we like to say that the solution to uncertainty is diversity. So it's the same way that it works in nature. There's not just one particular type of tree, there's many types of trees. And as different climates occur throughout the world, different kinds of flora and fauna will change to adapt to those changing conditions. I think we need that kind of diverse thinking when we think about this. Let me give you an example. Let's take plug-in hybrid electric vehicles. These are vehicles where for commuting for shorter trips, they actually run just like a battery electric vehicle. You plug them in at night, you then drive them around wherever you want to go. But if you have to suddenly change your mind and take a longer trip, you don't have to worry, well, will there be a charger there or won't there? If it turns out that there's not, you can still use the gasoline that's in the car just like a hybrid vehicle and have a very long range on that. What does that do? When you have a vehicle like that, your net consumption of fuel in terms of gallons per year goes significantly down. Well, that means your sensitivity to the price of that fuel is also going down. And so the net operating cost of having that vehicle is not so sensitive to the price of the fuel. It opens the door to the potential of using low carbon liquid fuels even if they cost a little bit more, because it's actually not going to change your budget for the operation of the car that much. So there's various synergies that we see even with new cars. And again, it's not the case that everybody can switch suddenly to battery electric vehicles and have the same kind of usefulness of a vehicle that they have now. Some parts of the world, that's definitely true. Other parts of the world, it's not going to be for some time. So in those parts, for those customers, I think that this has a role also for new vehicles.
The other criticism, I guess, would be that this is big oil, big car, big auto, trying to slow down the energy transition by showing that the internal combustion engine can last longer than policymakers think, by showing that there's a lifespan for fossil fuels that fuel those vehicles after 2030 or 2035, when many governments are talking about banning the sale of internal combustion engine vehicles. Yeah. How do you respond to that? Because that is, I mean, that, on the surface, that could be the response that you'll get across the country. You know, this is Chevron just basically trying to keep things as they are. This is Toyota trying to protect its internal combustion engine vehicles.
Well, I'll say, you know, we're extremely proud of our relationship with Toyota. We think Toyota is a tremendous company that's got an more than 80-year legacy of delivering affordable cars to people that have wanted them. Chevron's got nearly 150 years of delivering affordable, reliable, and ever cleaner energy. You know, we have, the things that our company and the people in our company have done have improved people's lives for a long time. We will continue to do that for a very long time. We believe the future of energy is lower carbon. That's what we're talking about. We need alternatives. And one of the neat things that's happening here is two companies with a lot of really, really smart people have gotten together and figured out a solution through innovation, creativity, and people power that is a really good alternative for the people on the planet. So I'd say it's a demonstration of what can happen when Chevron and companies like Chevron and Toyota get together and start to work really complicated solutions.
If I could sort of add to that, I think the most important thing to realize is that a battery electric vehicle only solution will not result in as much CO2 reduction as a multiple pathway solution such as we're exploring here. If that were the case, we would be fully in favor of saying, let's only switch to BEVs. So I think it's important for the public and for policymakers to really think clearly about this thing. Again, CO2 accumulates. It's not just about saying, well, 20 years from now, the situation will be different. Let's go ahead and accelerate that change as much as we can and pretend that it's 20 years from now and just bang, it's just all going to happen at once. It's just not true. And so during that transition time, how do we minimize the CO2 that goes out into the atmosphere? And the answer is to do more than just sort of wait for everything to change into battery electric vehicles. Let's also reduce the carbon dioxide that's going to come from lots of other places as well.
Okay, and when you look at this, Gil, when Toyota looks at this opportunity, you mentioned earlier that, you know, in poorer parts of the world, this may be an effective instrument to reduce their emissions because there may not be the same appetite for electric vehicles, I suppose. When you're scanning the globe, do you see any countries that are particularly suitable for this, other than the US?
I actually think that it is useful everywhere in the world. And the reason is because of units in operation. There are, you know, internal combustion cars, as I mentioned, 1.3 billion of them throughout the world. And there's not enough capital in people's pockets to go ahead and say, okay, this year we're all going to change our cars to the other type, and we're all going to create this, you know, huge amount of waste as a result of doing that. That's the wrong answer. The right answer is to do that transition as quickly as is economically optimal, and to also reduce carbon dioxide during that time as much as possible. So it's an optimization problem. And the optimum is to try to use these low carbon liquid fuels in the remaining internal combustion engines, which are practically going to be there for some time.
Mm-hmm. Okay. And Andy, when you look around, how big do you think this market for renewable gasoline will actually become? I mean, Chevron pumps a huge volume of gasoline and diesel every day. Just, you know, is it going to be a sliver of those liquid volumes? Is it going to be 10%? Is it, you know, how big could this get for you?
So I've been with Chevron for a long time, more than 30 years, and I've watched transitions happen. We used to have leaded fuel. We no longer have leaded fuel. We didn't have ethanol. We now have ethanol. I believe down the road, I don't know if it'll be in my career or well past my career, but I believe all liquid fuels will have a lower carbon intensity content to them. They'll be different in different stages, in different locations. Some can afford it, some cannot. But I think this will be where the liquid fuel market is going. It'll happen in some geographies faster. It may not ever happen in some geographies, but I believe that's where it's going to go. And I think that's kind of what's happened in the business I've been in for a long, long time.
Do you need government support for this? And if so, what is the nature of it? Do you get government support from the Inflation Reduction Act? Is this a factor in the way you've been thinking about it?
Yeah, so it is a factor. It is I think what's important is we believe that there should be a price on carbon. That would, I think, incent innovation. It would incent creativity. It would incent the most efficient way to lower the carbon intensity. We would like policymakers to have a level playing field. We would also like them not to pick solutions that are 10 or 15 years out or they're already picking winners. We think if they have policies that drive down carbon intensity, smart companies like Toyota, Chevron, and others will figure out a way to do that and deliver that economically to the consumer.
And speaking for Toyota, we don't take a particular stance on whether there should be an explicit price on carbon in this way, but there is an implicit cost of carbon that is true regardless. And we know that, as I said before, every bit of CO2 that goes into the atmosphere is going to be with us for many, many generations to come. And that is a cost that all of humanity around the world is going to bear. So whether we write it down or not, there is a cost of every gram of CO2 that's going out into the atmosphere. And again, whether policymakers make rules that are based on a pricing scheme, nature is making a rule saying that there is a cost to that CO2. And our responsibility, however it's done, whatever policy is used in order to do it, is to ask the fundamental question: how do we reduce that accumulated amount of CO2? Which we think the natural way to think about it is reduce it as much as possible, as soon as possible. And the result of that kind of thing is to say, okay, what can we do for existing cars? What can we do for parts of the world that aren't going to transition so fast, et cetera? And that leads to this, very strong partnership that we have here in trying to develop these low carbon liquid fuels.
And there are policies today that incent biodiesel or sustainable aviation fuel. Some of those things were worked on in the Inflation Reduction Act, and some of those things need to apply to all transportation fuels. And that's kind of how we would think about it.
Is there anything in the Inflation Reduction Act specifically for it?
No.
No.
It's focused on diesel, biodiesel,
Yeah.
sustainable aviation fuel.
Okay, and you mentioned a carbon tax, but as you know, the politics around a carbon tax in the US are pretty tricky. It doesn't look like there's going to be a carbon tax anytime soon. There is in Europe, effectively, a carbon price. Why not just do that there, where the alternative existing fossil fuels are also a lot more expensive? Why not try doing this there?
Well, Chevron doesn't have a marketing position in Europe, unfortunately. We don't have any Chevron stations in Europe to sell to, so we don't have any customers there. We're focused on the markets where we are. And yeah, I understand that a tax on carbon's difficult politically, but I think these are difficult challenges, and not only do companies need to rise up and solve these problems, but we need policymakers to have that same kind of, that put the same kind of effort into those opportunities.
Part of the way that we think about it is we want to give every customer in every walk of life an opportunity to contribute to the solution for climate change. And we actually know that people care. And even if the fuel costs a little bit more, people do make judgments for themselves saying, can I do my part to contribute to the solution to climate change? What do you do if you don't happen to live in a state with a lot of renewable power to recharge a BEV and you still want to contribute to climate change? What do you do if the lithium supply is short and the price of the BEV that would fit your lifestyle is out of range? People don't have an infinite amount of personal money to pick a particular car that is unaffordable to it. And we care about affordability a lot. We make cars for people of very modest means and wealthier people as well, and we want to serve all of those customers. And with regard to climate change, we think that a lot of people will actually vote to say by themselves, I think that this is a worthwhile thing to do. And I need a vehicle that will actually fit the life that I have and the circumstances of where I live. And so I think it actually makes sense all over the world.
And do you hope that in proving the technology or the fuel or the efficacy of the fuel, as you've been doing on the road trip, do you hope to persuade policymakers to be a bit softer on the way that they phase out the existing vehicle fleet? Is that the ambition, is to give a bit more life, get DC, California to be a bit softer on the way it's treating internal combustion engines?
So the way that we say it, we want to be very careful to make clear that we are not trying to slow down the transition at all. We want the transition to happen as soon as possible and as soon as practical. With regard to the specifics, I'm answering kind of from a scientific point of view. Mm-hmm. I think the transition is going to occur at the speed that it will. I think the bottlenecks are not actually policy. I think that the bottlenecks are physical in terms of the mineral supply and also the speed of the rollout of renewable recharging infrastructure. Given that timeline, given that time scale, we know that that transition is going to take time and will be different in different parts of the world. And so we look at that and we say, okay, there will be these numbers of internal combustion engines in those parts of the world for some time to come. What do we do to reduce the CO2 that comes from them? That's actually the motivating reason for doing it. It's not trying to slow down the transitions to BEVs. We are also completely trying to make our transition to BEVs as much as possible, as soon as possible. That doesn't say that it's instantaneous.
Mm-hmm. I'll just add, we agree 100%. We believe the transition needs to be faster. It needs to happen faster. Alternatives will help with that. And creativity and innovation that hasn't even been thought of is an important part of that. So if you open the aperture for all alternatives and you don't mandate or have arbitrary bans on certain technologies, I think things that we haven't even created today will be coming at us in 5 years, 10 years, and those are going to be solutions we're going to need as well.
But to be clear, this is going to start happening. Small at first, very small. Any indication of what kind of volume we can expect? You said later this year there'll be some some pumps in California. How many barrels a day of this stuff can you supply?
So it will depend on the consumer, but we will have it available at your local Chevron station at a few locations in California this year, and we're going to learn quickly with Toyota. We're going to try to figure out what happens, what's the reaction, how do you market it, how do you sell it, what are people prepared to pay? All of those factors are going to go into the speed in which we can roll out. Policy will be involved. All of these things. Again, if I were good at predicting the future, I would not have the job I have today. I'd be doing something else. But we're committed to this. We're going to put the resources behind it. We are going to push it, and we're going to try to make it work.
And you said you don't have marketing opportunity in Europe, but you do stick products on a boat and ship them around the world. Could you be doing this with that?
We actually do that. We actually do sell diesel, renewable diesel in Europe. We've got a couple of great plants that do sell into Germany. So we are a customer. We're not a retail customer into Europe. We don't send retail gasoline over to Europe, but we do sell renewable diesel. It's been a good market for our business, and we intend to stay there and continue doing it.
Let me address one of the questions that you asked, which was about customer acceptance. Are people really going to want to put this in their cars?
Right.
Besides a home, a vehicle is one of the highest priced things that people buy, and so they invest a lot of their hard-earned money in the car that they buy. And in addition, people love their cars, right? And they don't want to hurt their cars, and they certainly don't want to put a fuel in it that is bad for the car. I think that traditionally this has been sort of a push system where policymakers have kind of pushed the idea of changing the formulation of fuels because it is good for society. There's nothing wrong with that. We're wondering whether this could actually work as a pull system. It's sort of a different way of thinking of it. And we offer it to customers and say, look, you can help do your part to prevent climate change by buying this kind of fuel. And we, Toyota, are actually working together with Chevron because we know that it's not going to harm our cars. Even a brand new car that you just get, it's not going to have any effect on the warranty. It's not going to change the performance of the car. You don't have to change what the maintenance schedule is. It's truly a drop-in fuel for the vehicle. And in addition, we're also saying that it works for older cars too. And that's quite a difference from the typical things that have happened when formulations have changed in the past. When lead was taken out of gasoline, when alcohol was added in, there were all of these concerns as to, well, what happens if you have an old car that doesn't happen to match up here? In this case, it's actually quite different. And it's particularly important because so much of the reason for doing this, not all of the reason, but a lot of it, is for units in operation, for cars that are part of the existing fleet that will exist for some time.
And Andy, just to be clear again about the business case for this, this will have its own P&L in Chevron, or this is a genuine effort to make money selling this renewable gasoline, or is it a kind of a loss leader to show that you want to have fuels that are out there that will help decarbonize in this interim period before batteries arrive?
Well, the people that built the value chain that currently exists today, that came way before me, they took risks. They had to make decisions that were not obvious. They had to make bets into the marketplace, and we enjoy the decisions that they made, and the system works, and everybody has reliable, affordable energy to get to work and school. I'm telling my team, lean in, because we're starting to create the future for the people that come beyond us. Yes, Chevron will want to make money on it. Toyota will want to make money on these cars, but we also think that's what our customer wants. And it may not be easy. It may not be early wins in the first year, the second year, but I think this is where the world's going, and we're leaning into it, and I'm trying to encourage my team to get going.
Okay, well, we have some questions from the audience, and I'll remind the audience that after this is over, you'll have the video on demand for, I think, 30 days. So let me pose some of the questions that came in from the audience. Let's start with you, Andy. Do you foresee a market being developed, I guess a global market for this kind of renewable gasoline in the way that there is for normal gasoline, normal products?
Absolutely. I think there's a market today. We're going to test it out later this year. We're going to learn from it. There are other geographies, not just in the U.S., that we're going to explore. We have a big position in Singapore and Hong Kong, some other places in Asia. We have a Korean joint venture partner that'll be looking at this stuff. These are markets where the customer is asking for this stuff, and you know, we're at the demonstration stages today. We drove 1,000 miles the last few days. It works in the vehicles. Come talk to me in a year, and I'll let you know how it's going, I guess.
And Gil, does Toyota
Yes.
see this as a genuinely global phenomenon at the moment, or is this kind of, again, a loss leader that can show your
Yes.
credentials, if you
No,
like?
I assure you there's no greenwashing going on here, just to answer your question as directly as possible. The UN, the Intergovernmental Panel on Climate Change, IPCC, in their latest report, version 6, actually addresses all of these sorts of things. And what it shows is that if you look at the amount of carbon reduction that can be accomplished by different sorts of efforts, that improving the fuel economy of vehicles actually has more potential to lower immediate carbon emissions than changing to BEVs. Now, that's not to say that you choose one versus the other, but it is to say that if you do both, you can more than double the amount of CO2 reduction that you can accomplish. And from our point of view, having customers be able to afford to replace their older internal combustion engine car, which gets low mileage, with an electrified vehicle, if they can't afford a BEV, that would be a PHEV or an HEV that has much higher fuel efficiency than the ICE, is incredibly good for the environment. And it's not just us saying that because we want to sell cars, it's actually the IPCC that's saying that. And so can we improve the fleet efficiency? And then on top of that, can we fuel those cars with a low carbon liquid fuel, which then boosts it by nearly a factor of 2 even more. And so there's incredible potential here, and we don't have to wait for the BEV transition to be complete in order to begin to get those benefits.
Andy, another question from the audience, and this one, I guess, is similar to one I asked earlier, but this is posing the question more directly, which is why focus on motor fuels at the moment when there are other hard to abate sectors that Chevron could be doing a lot more in, including sustainable aviation fuels. I know you're doing some of that as well, but why not just throw as much at that, given that there is an alternative that's coming down the pipeline, however long it might take, in the passenger vehicle fleet, which is electrification? Why not focus all of your energies, or more of your energies, on sustainable aviation fuels or some other harder to abate sector?
So again, good question. I'll go back to a lot of Gil's talking points. We are focused on the hard to abate. We're doing what we can there, but we can also do something here, and we've got to start now, and we can't wait for everybody to have an electric vehicle. We can lower the carbon emissions of 265 million vehicles in the US. It's going to take time, yes, but those vehicles are going to be on the road a long time. Why wouldn't we want to go after that with a relatively affordable solution that goes through the current infrastructure today, that lowers the CO2 emissions of that person's car today? We think it's an obvious opportunity to take CO2 out of the air and do it sooner. And I think do it cheaper. And so that's why we think it's a good solution. That's why we've partnered with an important company like Toyota. And we think it's the right thing to do.
And is there an opportunity to do, kind of have a synergy in the production of the sustainable aviation fuels by using the naphtha, or how do you, is there any kind of way that the refinery itself can?
Yeah, there are some synergies. Really good question. In one of our big facilities at the El Segundo refinery, it makes both gasoline, jet, and diesel, renewable gasoline, jet, and diesel. All of those products can go out to the market, and that's what we've done already. We've tested it once. We're going to do it again. That's how we make renewable gasoline. So it's all those products, and they all go to different sectors and different transportation modes.
And besides the synergies that Andy is mentioning, it's also important to think again about the time axis. That if this were a question of, let's say, 50 years from now, which should we choose? The answer clearly would be, okay, let's try to put the synthetic fuels in the hardest to abate sectors because of the alternative that you mentioned of BEVs, right? Mm-hmm. But it's not 50 years from now. And again, between now and 50 years from now, all of that CO2 that will be emitted will accumulate and will stay around for hundreds, if not thousands of years. And so we still have this big lump of CO2 that we need to address, and that's the reason that you want to use low carbon liquid fuels, not only in the hard to abate sectors, but in vehicles also. And carbon saved burning these fuels one way versus the other way, it's the same CO2. The air mixes it all. So yes, in terms of looking out into the future, the R&D that we do is definitely synergistic between the different fields, but there's no reason not to use them also in the legacy fleet in order to reduce that net CO2 that will be emitted.
If this is going to be a game changer, if you like, for emissions from passenger vehicles, or the gasoline consuming vehicles in the US. I mean, there's 13 million barrels a day of gasoline consumed in the US, I think, roughly. Scale will be of the essence, presumably. Otherwise, it's just a peripheral nice thing to have, right? So, Andy, how do you actually go about getting the scale? I appreciate that, you're going to have some fueling stations in California by the end of the year, but what it really needs is fueling stations that are converted to this stuff across the country that will be able to fill my terrible vehicle at home that's still belching out fumes. And that needs to happen really quickly, otherwise it will be overtaken eventually by the electrification. No? I mean, there's this window, you need huge scale in a relatively short window, I guess.
Well, I'm not sure. Again, I'm not really good at predicting windows. I don't know how long that window is. We are getting after this. We're glad we finally made this announcement. We've been working on this for several years. It's time to get out there. Our competitor, the refining business, not just Chevron, my competitors need to be thinking about the same thing. Other automakers need to be thinking about the same thing. We've got to start to make this a solution for the consumer. And that's what we're talking about today. That's why we're here. That's why we did the drive. We wanted to prove this fuel out. We wanted to demonstrate to people that it works. And I don't know what time T is, because it may be short, it may be long, but this is certainly an alternative that makes a lot of sense.
What I can say a little bit about this time T, there's something called Amaras Law, and it has to do with a human tendency to overestimate the speed of technological change in the short term and to underestimate it in the long term. And we've seen this many, many times. In my research lab, for instance, 8 years ago, we were working on automated driving, and we were the few companies that actually raised our hand and said, sorry, this is actually going to take a long time for the following reasons. And there was tremendous hype and tremendous sort of overestimation of the rapidity of that technological change in the short term. In the long term, we're certain that it is going to happen. I think with battery electric vehicles, it's very much the same thing. And we need to remember, in technological speak, it's called a double integral that needs to occur, which takes time. And so first, we need to actually convince customers to buy BEVs. And so we need an accumulation of a conversion of customer preference that they want to buy BEVs, and the incentives are all helping with that. That's the first. And then the second one, we need the fleet to be replaced. And that takes time too, because the existing fleet has to have new cars accumulated in it until that converts over. So it is going to take some time until that curve switches over the fleet. And again, unfortunately, CO2 doesn't care. CO2 accumulates. And so how are we going to address that issue and lower that mountain of CO2 that's going to be made?
Right, but this isn't a bet against the energy transition or an effort to stop it. It's a kind of a bet against the pace happening as the optimists think.
I think even the optimists, and I have many friends and colleagues who are part of that camp, and I'm an optimist myself. I think if you really ask them, draw out those curves and how long it's going to take, will show you that there's a lot of internal combustion engines for quite some time, particularly if you take a global point of view. And so, okay, that's just going to happen. And so what do we do about it? And that's the answer here.
Okay, and Andy, I mean, there's been a lot of talk over many years in the oil industry about alternative fuels and algae and all kinds of things that haven't really penetrated the mass market, let's put it that way. Why, and this is one of the questions from the audience as well, it's a good one, why is it actually going to be different this time? What makes this different from a bunch of the other experiments that have happened in previous decades?
Well, it's the reason it's taking time is difficult. It's been difficult to create alternative fuels that work. I would say that we're already there. We're getting there. We have a lot of renewable feedstocks that go into fuels. People are building renewable diesel plants. People are building biodiesel plants. We're able to make renewable gasoline. I think we're there. We have to keep expanding the technology. We have to keep expanding the opportunities around feedstocks. There's things called cover crops, and algae's not, that's been difficult, but it's not dead. There are nuts and seeds and all kinds of other things that are gonna contribute to this feedstock, and we're plowing, investing into it. We're trying different things. We're leaning in. Our competitors are too, and I think we're on the road to figuring this out. I'm not nearly as negative as you sounded in your question.
Well, I mean, I think there's just a presumption among the population at large, I guess, that it's in your interest to keep the existing transport system in place. It's in Toyota's interest to keep internal combustion engines viable for as long as possible. It's the question I raised earlier.
Sure.
So, and they have heard, the industry has spoken a lot in the past about how it's going to find new ways of forming or creating liquid fuels. So I think, what should we as, let's say, your skeptical audience, be watching for? What are the signposts that we should be looking for that say this is actually happening?
Well, I'll refer to things that we are doing and things we've done. Chevron last year bought a company called Renewable Energy Group out of Ames, Iowa. Tremendous group of people. Mm-hmm. They're experts at finding feedstocks, talking to farmers, talking to aggregators, collecting used cooking oil. Those people are really helping us. That is a demonstration of action where we put real money into a company, brought that capability in. Those people are now part of Chevron. They're now helping us figure the next phase out. They're working on algae. They're working in Argentina on a different tree, a nut, and those are signposts I think people should look at as to our commitment, as to what we're doing and why we're doing it.
The other signpost that I think is very important is actually the flip side of optimism. So there is growing pessimism, as I'm sure many of your viewers know, of whether we're going to be able to meet the 1.5 degree target from the Paris Agreement. And I think the pessimism about that is actually a positive force, okay? The worsening weather is a positive force. These things are making people say, look, what we're doing is not enough. And in addition to sort of increasing the depth, saying we have to transition even faster, I think it's also increasing the breadth of thinking, saying, are there other things that we can do in addition to the transition to battery electric vehicles? And I think it's actually creating a lot more clear thinking, and the upcoming COP, as an example, is trying to think that way much more than previous ones have done, which is kind of wishful thinking. Well, I wonder if there's a silver bullet that would fix all of these things. And the answer, it turns out, is that there isn't. And so we have to increase both the intensity of what we're trying to do with our transition to battery electric vehicles. And despite the thought that, it's good for us to sort of not work so hard at that, we are working as hard as we can. And I mentioned before, The numbers of 3.5 million vehicles per year is our target for 2030, which is only 7 years from now, and 1.5 million vehicles per year as BEVs only 3 years from now. So that's an incredibly intense effort that honestly is saturated. That's as fast as we can possibly go, but it's not enough. It's not enough to meet the target. So how can you mitigate climate change, which is incredibly serious? You have to think broadly as well as deeply.
And Andy, last question, if I may. There's this huge need for scale, speed to roll this out. What is it that you need from federal government in terms of support, from states or from industry? What is it? Are there any hurdles that you foresee that can be fixed with, the stroke of a pen from Joe Biden, or what?
Well, look, I think what we're going to do as an industry is we're going to get a plan together, and as an industry, we're going to go and talk to policymakers about what's the best thing. We've not aligned on that yet. We need agreement from automakers. We need agreement from agricultural, ethanol, ag, soybean. We're having those conversations about how do we figure this problem out, and then what policies do we need? I don't want to get ahead of that. We're working hard on it. We've been working on it for a while, but we will have a solution that makes this viable, makes it so we can scale it up, and does exactly what Dr. Pratt's been talking about.
Well, I look forward to filling up my vehicle in New Jersey with renewable gasoline. Gil, Andy, thank you very much.
Pleasure. Thank you.